Okay, hey guys, I will be seeing you guys on Tuesday, and this video is going to be, I don't know if you can see how the cursor right here on section 4.4a, square root, radicals, and complex numbers. So that's what this video is about. I wanted to show, and I know I'm using Black Widow's topics as an example, but it's the same for Storm, my Block 5 group. But basically, we have already covered section 4.2, solving quadratics by graphing and tables. Remember, this is when we can use that formula x is equal to negative b over 2a to solve for the x coordinate of the vertex, and then taking that x value, we can plug it into our function and get out our y and get the vertex, and then we can make a table of data. And we can then start to plot some additional points on the left and right side of our vertex, or you could just make a t-table from the start, plug in some negatives, 0, and some positives very carefully into the function, and then of course plot those points and make your parabola or your quadratic function. The next thing we've already talked about was solving quadratics by factoring. All of us have different ways of going about factoring. I modeled in class, and we worked with our partners with the way that I do factoring with the FOIL method and do guess and check, but you're more than welcome to use any strategy you want. Just make sure that you can completely factor down any type of quadratic function or equation that I give you. Remember, sometimes it's to factor, sometimes it's to solve. And if you have to solve a quadratic by factoring, then you're finding the x-intercepts or the roots or solutions to the function. So those are your x-intercepts, okay? Real quick, I'm going to open up the lab. And again, this is Black Widow's lab. And again, we've covered 4.2. Make sure that you use these I can statements to check off what you know how to do and what you don't know how to do or what you're not comfortable with at this point. 4.3 also, we've done this, so make sure you understand these particular types of things like recognize and use, the difference of perfect squares, perfect square trinomial patterns, and then again today we're going to talk about 4.4a. Now, one thing you notice in the lab as I kind of go through is I don't see where we have a concept check, so again this unit's going to go pretty quick, but what I can do is we should go over the homework assignments after we do, or a little bit before we begin the practice for 4.4a. So we will go over these homeworks, and I will have those solutions ready for you, and you can tell me what you do or do not feel comfortable with. But let's jump into the video, okay? So I'm going to open up the PowerPoint, and this first particular slide here, as you can see, is all about reviewing 4.3, which is factoring, and I'm just going to do one of those, so give me a second. So I'll do the fourth one, and again, the other three I'll leave for you to do on your own. Okay, so for number 4, again, I'm going to show the way that I factored in class, and again, you're more than welcome to do whatever way that you would like. Okay, so I'm going to write right here. Let's click on my. So I have 2x squared plus 5x plus 3 equal to 0. So every time you see that it's equal to 0, that means you're trying to find your x-intercepts or your roots to the function. So in this case, I like to look at my a term. I write my factors, 1 times 2. My factors of my c term, 1 times 3. And then I write these 2 sets of parentheses, like that. And again, I'm going to put a 1x in the front of here, the 2x, because 1x times 2x gives me 2x squared. And then it's a matter of just playing with the 1 times 3 and change their position, right, in the back here and here so that I can figure out how to get this 5. All right, so I'm going to try 3 here, and I'm going to try 1 here. All right, and then I do the FOIL method. Remember, FOIL stands for first 2 terms multiplied together, the outer or outermost terms multiplied together, inner 2 terms multiplied together, and your outer and inner terms are like terms, so they always combine. And then L stands for last 2 terms multiplied. Okay, so I'm going to just draw some lines so you can see what I'm doing. 1x times 2x is 2x squared. 1x times an outer is just another 1x. Inner right here is going to be 6x. And then my last 2 terms, 1 times 3 is 3. Now again, what I do is I add these together. So if I do 1x plus 6x, that gives me a 7x. But remember, I want a 5x, so that doesn't work. I'm going to erase that. But if I subtract these two, okay, if I subtract, 6 minus 1, that does give me a 5, and then it's about the sign, okay? So I want a positive 5. So I want a positive on the 6, a negative on the 1. And see right here in the middle, this 3 times 2, that's where I got 6 from. So I want to put a plus on the 3. We'll put a minus out here on the outside. Okay, so now I've achieved this 5x, but here's the last problem, okay, is if I do positive 3 right here times negative 1, you see that will give me a minus 3, and I wanted a plus 3 up here. So basically that means no, this positioning and these signs don't work, okay? So I'm going to erase this stuff here, clear this up real quick. I'm going to go back, put the 2x back in here. Instead of me putting my 3 here on the inside, I'm going to put the 3 here and the 1 there. And let's do this again. Okay, so again, I know that my 1x times 2x still gives me a 2x squared. And then I know that my 1 times 3 gives me a 3. So these two terms in the front and back don't change. So let's look at the inside and the outside. So if I do 1x times 3, which is the outer terms, that's a 3x. If I do 1 times 2x, that's a 2x. And again, I want pluses on both of them because I want to get 3x plus 2x. And then if I put a plus here and here, then positive 1 times positive 3, it is positive. And then there is the 5x. That's what I wanted, okay? So now I said both of those factors equal to 0. And so what do you know here? X is equal to negative 1. So at negative 1 comma 0, that's one of my x-intercepts. And if I do 2x, if I do 2x plus 3 equal to 0, subtract 3, 2x is equal to negative 3, x is equal to negative 3 halves. Okay, so at negative 3 halves comma 0, that's my other x-intercept. So again, that's just a quick review over how to factor and then finding your x-intercepts. So I'm going to close this. Let's go on into the new material. Okay. All right, so now we're going to get into this one. So let me zoom in and make a screenshot of this. All right, so for radicals. So the way that you simplify radicals is you do prime factorization. And this is going to be a quick review from middle school about how to break a number down into its primes using the factorization or prime factorization tree. So you can multiply this down here to 10 times 8. Or you could have said 40 times 2, it doesn't matter. But when you break it down, we end up with the same answer, okay? So again, 10 is not a prime number, so I'm going to break that down further to 5 times 2. And 5 and 2, they are prime numbers. 8 breaks down to 4 times 2, and 4 breaks down to 2 times 2, okay? So now if I just circle all my primes, those are my prime numbers. Now real quick at the bottom, let me define what a prime is. This is just, again, a review. If you know it, great, okay? But a prime number is a number that is only divisible by itself in 1. By itself in 1, okay? So then in that case, now that we have it down to its primes, there's a certain way that you have to combine everything so that you get a simplified radical. So the way that I do this is I would say couples go out and singles stay in. So what I mean by that is because there is a 2 on this square root, even though we don't see him, pairs of 2's will come out. So I like to think of this as here's Mr. and Mrs. Smith, you know, these 2's here, and couples go out on dates, right? So instead of you saying, well, Mr. and Mrs. Smith went out, you just say the Smiths, right? The Smiths went out on a date. So I'm just going to take that pair, and instead of putting like 2 times 2 is 4 on the outside, it's just 1 2 that comes out, one pair. So I'll put a 2 on the outside. And then I notice right here, like the Joneses, there's another couple in pairs, and they're going out on a date. So they go out, so bring a 2 out. But the single guy here, that 5 is not with a pair, so he's going to stay inside. So the answer to this is 4 root of 5. Hopefully that makes sense. Okay? All right. Now let me also say before I go into the next one that if this would have been a cubic root, just for a moment, okay? I'm just going to, just real quick, if this would have been a 3 there, then we would have something a little different. Instead of pairs being what comes out, it would be sets of 3 would come out, a set of 3. So that means it would be these 3 guys are together and 1, 2 would come out. And this 5 and 2 would be a single, okay? Because the 5 is by itself, and then of course the 2 is by itself. They don't have like 2 more other people to go with them. So the answer to this, if it was a cubic root, just showing you, it would be, 2 cubed root of 10. Okay, so you just always look at that root number to see, how many of those sets, that's what will come out. We'll do more practice in class, okay? But the answer is 4 root of 5. When you're multiplying radicals, understand that if you have the square root of a times the square root of b, it's the square root of a times b. So what we're going to do is we're going to multiply that square root of 6 times square root of 21. It's going to be the square root of 126. And remember, all radicals have to be simplified and reduced. So we're going to take this square root of 126 and we're just going to break it down. Okay? Now you can divide this by 2. Okay? And you would get 63 times 2, I want to say. Yep. But I'm going to do 3. Okay? I'm going to do 3. Oh, my kids. Okay. Sorry about that. Okay, so now what we'll do is I'm going to use 3. So I'm going to ask myself, 3 divides into 126. It goes in there 4 times for 12. 0, bring down the 6. And I know you guys can just do this. But so I got 42 times 3. Okay, I'm going to erase this little part right here. Sorry for the crying. Okay, so 42 breaks down to, let me hit my little cursor thing again, breaks down to 6 times 7, and then 6 breaks down to 3 times 2, but again, 3 is a prime number, 2 is a prime number, and then you have 7. And because it's a square root, like I said, these two are a pair, so a 3 is going to come out, and then these two guys don't have a partner, so they stay in. Okay, so the answer to this one is 3 root of 14. Okay, I'm going to erase. I don't know how these little lines got there. Whoops. Okay, alright, so that takes care of A and B. So now let's look at C. So for C now, there is a rule that says if you have like a fraction under a square root, then this is going to be like the square root of A over B. You can separate them. See, like the square root of A divided by the square root of b, so you can take them individually. And so the square root of 4 is 2. Okay, so this becomes 2 over, and the square root of 81 is 9. So the answer to this one is 2/9. And that takes care of that. Alright, so that is all of the answers on that slide. Okay, so now let's go on to the next one. Alright, so in this one, it's going over, let me just take a quick screenshot of this one. This one's going over addition and subtraction, alright? But the problem is, if you look at it, when you compare, let's say this example, I'm just going to underline it real quick. Compare this one to this one, you notice that, all the numbers are really different. So it's really important that you simplify, I'm going to write this on the side, you simplify the radicals, and then you see what you can combine when you're doing addition and subtraction. So in this case, on the one to the left, see these two can be combined because the root of 7, it makes these where they're like terms. Okay, so they have the same root of 7, so that means the answer is you just add whatever's on the outside together. So the answer to this one is 5 root of 7, and you're done. Okay, now in this one it's a little different because you have the square root of 45, the square root of 20, and the square root of 75. So as you can see, they're all different. So we're going to just start doing that prime factorization to break them down and then see what we can combine. So we break down the square root of 45. I'm going to put 9 times 5. This one's 3 times 3. So the square root of 45 becomes, again, remember I told you it's a square root, so pairs come out. Just one pair of that number comes out, so we have 3 root of 5. Okay. If I break down 20, I'm going to do 5 times 4. This breaks down to 2 times 2, and again, these are my primes. But again, that pair comes out. Now remember, there is a 3 already on the outside, so I'm going to multiply this by 2, because the 2 comes out, and then the single stays in. So I'm going to just rewrite these two terms. So 3 root of 5 plus 3 times 2 is 6 root of 5. Okay? And now I'm going to do 75 here. And so we got to think about what times what gives me 75. And so the answer to this one is going to be 15 times 5. Okay? 5 is a prime number. I can still break the 15 down to 5 times 3. And then again, here's the pair. So I'm going to change this one, and don't forget that subtraction symbol. So I'm going to put a minus, and a 5 is going to come out, and the root of 3 is going to stay on the inside because that was the single. Okay? So I'm going to drop this down. And so now what can we combine? Well, these two have a root of 5. So I'm going to basically add 3 plus 6, which is 9. So 9 root of 5 minus 5 root of 3. And that's all you can do because, again, they do not have the same square root value. Okay, and that takes care of when it says the combining like terms radical review. Okay, so I'm going to close this one. Let's go to the next slide. Alright, so now we get into this I. And so I is called imaginary. So let me take a screenshot of this. Whoops, hit the wrong button. Okay, so to fill this in, it says the number I is called the imaginary number, where I is equal to the square root of -1. Okay, and there's no such thing as negative square roots, and we'll get into that over time. And I squared must be, so if I was to square this, you guys know that the square root or the radical would go away and it just leaves me with -1. So the answer here is I squared is equal to -1. I'll go back and fix this here so I have the right thing. Again, square root of -1. So again, I is equal to the square root of -1. I squared is equal to -1. So now any number with an I is called an imaginary number. I don't know why we have that twice. And I will kind of, if I find something else to put in this blank here, I will. But the number I is called the, I don't know, I gotta look that up, but it's an imaginary number. That's what I is. Alright, so now let's go to the bottom here. Write each of the following in standard form. So basically, if we have the square root of -9, the way that I think about this is, first, if it's a perfect square, you just want to take the number of that. Just ignore the negative for a moment. So I know the square root of 9 is 3. Okay? And so it's a perfect square, so I'm going to put 3. But then because he was negative, I have to put in the I. Okay? So the answer to this guy is 3i. So one more time. I first took the square root of 9, positive 9, which is 3. But because he was the square root of -9, I had to bring in the I to show that he really was the square root of -9. Okay? So I just put 3i. Alright, so now, and I think I cut the screen off too low, so let me go back. Yeah, there was some more here, so let me screenshot this again. Okay, so now for this one, we have the square root of 12. And so for this one, I'm going to think about just first breaking down the radical of just the square root of 12. So this is how I do it. So I have the square root of 12, which I know breaks down to 4 times 3, and this is 2 times 2. And remember I said, you know, a pair comes out. So if I had positive the square root of 12, it would be 2 root of 3, because again, the single stays under the radical inside. But because this is a -12, and again, I'm going to put back up here that 3i, a negative, I have to put in the I. Okay, so the I is going to be on the outside. Okay, so the answer to the square root of -12, and maybe so that's not confusing. Let me erase that out. That's if it's positive. But this answer here is 2i root of 3. The I should always go on the outside of the radical. Alright, now for this one, same thing. There's nothing to do to the 6 because he's positive. Plus, and because I have that square root of -4, 4 is a perfect square, so I know the square root of 4 is 2. But because he's a negative, I'm going to put an I in it. So basically, I'm going to leave the 2. There's multiplication happening, and I'm going to put a 2i. Okay? So the final answer should be 6 plus 4i. Alright? And that's the answer. So we'll do some more of those in class, and please come with questions. So let me close out of that. Let's go to the next one. There's not very many slides in this particular lesson. Okay, so they're doing a couple more of these. Let me get another screenshot. Alright, so for this one, same thing. I told you, I break them down like they're positive, and then I put my I back in. So for this one, I know that 7 times 4 is 28. Again, I'm ignoring for a moment that it's negative. I'm just breaking it down doing prime factorization. This times this is 2 times 2. There's my pair, here's my single. So if I was just the square root of 28, the answer would be 2 root of 7. But because he's a negative, I'm putting the arrow on the negative, the answer to A is going to be 2i root of 7. Alright, same thing with 45. Break down positive, the root of 45, which is 9 times 5, 3 times 3, circle the pair, box the single. So this guy normally would have been 3 root of 5, but because you have the negative, it's 3i root of 5. Put the I on the outside. Okay, pretty easy. And then for this one, for 50, 10 times 5, 5 times 2. Okay, here is the pair, and there's the single. Whoops, sorry about that. Here was the single. And so this would be, if it was positive, the root of 50 would be 5 root of 2. Again, remember the pair, that number comes out, and then that single stays in, and there's a negative. So 5i root of 2. And then for 32, break this down to 8 times 4, 2 times 2, 4 times 2. Again, you're trying to break it down to primes. And now in this case, I have 2 pairs. So this is a pair for me. Here's a pair, and then this guy is the single. So again, if this was positive root of 32, it would be a 4 root of 2. Because again, I think of this 2 and this 2, and I multiply those 2, and then that's my single. But because it's negative, putting the arrow on the negative, it's 4i root of 2. So I hope that makes sense, okay? And I'm trying to think. Not many more slides left. So now we're going to look at this slide here. Whoops, I hit the wrong thing. Okay. Alright, so for this slide it says a blank is one that is made up of blank and then blank. Alright, so if I look at this bottom down here, so we got real numbers, and then we have imaginary numbers. Okay, so if we look at a real number, and I don't know if you can see this down here, but basically a real number, you know, it's just like 3, 4, -2, 6. Okay, and then there's no imaginary part. So they gave you some examples down at the bottom. But imaginary numbers have 2 parts. They can have a real part here, and they have that imaginary part, which is the I part. And like they say here, B cannot equal 0 because that piece does exist. So I think what we should put on this slide here is a complex number. So let's put complex number is one that is made up of a real part. Okay, and that part I guess we'll just denote as our A. I don't know why it's doing that. A. And an imaginary part. That's the B part with the I. Imaginary part. And then, like I said, I'm going to put BI there. And in standard form, a complex number is written as, and that's where we just put A plus BI. Okay, so we'll get into complex numbers these next 2 slides. So hopefully that fills everything in for you there. Alright, now we move on, and so now they're going to talk about it. And they're saying, let me make another screenshot. Find the value of x and y that make this equation true. So the cool thing about this is, the first thing I notice is, well, you're my real part, so that's my a. Then there's a minus sign, and then over here, this is that bi part. And I'll just drop down the minus. And then I notice in my equation here, I got this 2x, and then that yi has the imaginary part. So I'm just set up two equations separately. So I'm going to do 2x is equal to negative 14, solve for x, I'm going to get negative 7. Then I'm going to do yi, okay, that's being multiplied together, is equal to negative 3i. And basically just looking at it, if the I is just, my imaginary part, y must be negative 3. Okay? And so that's what I would say. X must be negative 7, y is equal to negative 3. Now we move to the next one. Find the value of x and y that make the equation true. Same thing. Here is my real part, the a. Drop down the plus, and here's my bi part, the imaginary. So I'm going to set up two equations. 3x is equal to 15. Divide by 3, and x is equal to 5. And then for this negative yi, set that equal to 2i. Okay, and I would say the first thing I'm going to do is, because I have that negative yi and I want a positive y, so I'm going to divide by negative 1 on this side. What I do to one side, do to the other. So I'm going to have this positive yi, and that makes this a negative 2i, so y is negative 2. Not too bad, okay? Just sometimes even when you're presented things that you've never seen before, you just try to just take it in pieces and use a little bit of your reasoning and logic, okay? So I hope that was helpful. And the last one, let's talk about actually doing operations with complex numbers. So in this case, they're doing addition and subtraction. This is our last slide. So for this one, you can only, and let me just put another color, and let me put a little note, okay? You can only combine the real parts together, and then just in that regard, you can only combine the I parts together. So I'm putting another star. You can only combine the imaginary, and I'll use the little I, the imaginary I parts together. Okay, and this will make sense as I do the example. Sorry for the noise. Okay, so in this case, I'm just saying, if I was doing addition and subtraction, then I'm saying, hey, only the real parts, which that's my A, so 3 plus 2 is 5. And then when I look at, sorry, use another color, the imaginary part, so in this case I have 5i, sorry about this, 5i, and then I have that plus negative 4i, so we just do subtraction, and so this would be just a positive I. Okay, so that's what that would be. Let me put it over this way, I. So the final answer to this, if you were simplifying it and bringing it together, is it's take the real in the front, and then we got plus I. So again, combine the real part, 3 plus 2, that gave me 5, and then I had 5i plus negative 4i, and that gave me a 1i, and so my answer is to keep them separate. Alright, now with subtractions a little different, so pay close attention to this. The first thing you want to do is in front of parentheses that have minuses, there's a negative 1 there. So you want to distribute through that back parentheses first, okay? But before I do that, I'm going to go back because we do math from left to right, and let's just rewrite that first parentheses. Just drop those terms down, and now I'm going to do my distribution. So negative 1 times 3 is negative 3. Negative 1 times negative 7i is a positive 7i, so the integers don't change, the rules of integers. And again, I'm going to only combine my real part, so the 4 and the minus 3 give me a 1. Okay, and then I'm going to use another color. And the imaginary part, which is that negative 6i plus this 7i, that's going to give me a 1i, because I subtract. So the answer to this one is 1 plus I. Okay, let's keep going. Now we have addition again. Again, here's the real part. So 3 plus 2 is 5. Here's the imaginary part. So 6i and 4i is 10i. Okay, and I guess my screen got cut off. So again, this is the answer. Let's zoom out for A, B, and C. And I'm missing D. So I'm going to close this out real quick and go back to my right here. So I'm going to screenshot and just work this one separate. So for D, and I'm going to move up this way, is here's my real part. There's my other real part, but again, I see this negative, and that tells me stop everything. Let's drop down the front parentheses. Let's put a -1, and now we'll distribute that -1, which changes the signs. So I'm going to get a positive 2. I'm going to get a negative 5i. And then my real parts, 3 plus 2 is 5. 2i minus 5i is -3i. Okay. Alright guys, so that concludes this video on section 4.4. Okay. And so hopefully now, you have an understanding of what this section is about. And we've covered, again, I can simplify, add, subtract, and multiply with radicals. I can define what an imaginary and complex number is, and I can simplify, add, and subtract with complex numbers. So what I plan to do is let's go over the homework for this page here. We should have tried that. We also have already presented this, so let's take these, and then maybe in class we can just do this one together. So if you've not gotten to the homework, then now that you've watched the video, let's work on page 252 with our partners and do these 5 in class, and then go over those at the end and go from there. Alright, so here is your first flipped classroom. Okay,